Okay. So this is going to be a little, absolutely nothing build. Little 5 to 3.3 volt transformer that I'm going to build. I'm going to cut a piece of this prototyping board off. And I actually found this adapter. So the adapter was actually taken out of a cable box. This is a dish cable box that I found on the side of the road. As you can see, it's actually broke here when I put the heat gun to it. But yeah, I looked up something that would take 5 and turn it to 3 volts. I was going to make my own out of resistors and stuff, but I actually saw the L1117 is perfect and does 1 amp. So the whole reason I've started this transformer build is because I was charging an 18650 cell with the 3.3 volt on an Arduino, and I think the actual 3.3 volt regulator will do it, but the current resistor, the current limiting resistor on the transformer got super hot and just kept hitting thermal load, and it would bounce to 3 volts and then jump down to 1 volt, bounce back up to 3 volts. It just kept hitting thermal load, so I should have known better. I'm a noob, what can I say? So I picked up this board that I had laying around for a while, and I started looking around it. I pulled a lot of components. This whole jar here that I have of the 400 volt capacitor and a bunch of other capacitors and inductors and stuff like that all came off of this board, and so I picked it up. Sure as hell it had an L1117. So I hit the heat gun and popped it off of there, hooked up 5 volts to it without any capacitors or resistors or anything, and sure as heck put out 3.3 volts. So what I want here is something stupid simple. I want to bend out some rails and put them on to this chip, and I want to use, for right now, I just want to use the back side of the chip itself to clip onto with the alligator clip for 3 volts out. Eventually I want to put some female pin headers here, pin sockets, so I could do that and then have positive and negative off of here too, so I can throw voltage to it and then throw voltage off, you know, jumping 5 volts over. Just cool stuff. So for right now, I just want to bend some rails out, something I can just hook alligator clips up to it, throw 5 volts at it, expect 3.3 reliably, and go from there. So what I have open on the computer is the datasheet, one of the datasheets that's available online. The particular one I'm looking at is from DigiChip, and it says the basic fixed output regulator circuit, which is what I want. This happens to be also adjustable, so you can do an adjustable circuit on this, which will give you, I think, 3, 5, 8, and something else. So a few different voltages that this thing can actually do. Let's see. Now, yeah, it can do a few different voltages. I'm not looking at it right this second, but so I do see on the circuit that we're going to need a 10 microfarad capacitor on the input and a 22 microfarad capacitor on the output. It worked without that, like I said, so I'm just doing what the data sheet here says, because I'm actually building it into something. If I was, like earlier, I was just hooking alligator clips directly up to the chip. I threw 5 volts to it, it gave me 3.3 volts, no complaints, but obviously that's not very clean 3.3 volts. So this will actually be a lot better to jump stuff off and see if this can actually charge an 18650. It outputs 1 amp, and I think 18650s are about 1200 milliamp hours about. So I'm not sure how hot this thing will actually get, but we'll try it. And I was even thinking about getting a little heat sink and soldering this to the heatsink and using alligator clips to the heatsink to actually take off 3.3 volts. It would keep it cooler, and I could even stick the heatsink in water and pull 3 volts off of that actual board. I did that with an LM317 actually. It came with a heatsink that it was stuck to with thermal adhesive, and I put it upside down in a mason jar and let the heatsink sit in water. And I was, what was I running? I think I was running the PlayStation 1 off of it or something like that. Okay, so we're just gonna get started here. I want to kind of figure out where I want the heart of this thing first of all. So I've kind of calculated that the pad side here, you notice this is cut off. I'll count this last row here of holes. This pad area takes up about 2 holes worth of row, and that together, if I calculate it right, I can take 10 holes off of this side, put that in the middle, and I'll have about even spacing on either side, and I can still use the pads for something else later. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the next hole goes in. So this is where I want the chip to sit ultimately. So leave that there. I'm going to go ahead and fire up my soldering iron. Go. There. A little bit of water to her. That's good. Probably a little bit much. Trash can. Wanted to eventually add a switch to it, but I might do a whole bunch of stuff with this later, so I'm probably not going to cut this board up. I'm probably just going to leave as much as I can on either side for you know, other stuff later. Turn that on. Give it some flux. This thing actually gets hot pretty fast. I love this soldering iron. I've done quite a bit of soldering with it already. And this one tip, I have 2 other tips that I haven't even used. This one tip, as soon as I turned it on and got it hot, before I even got it tinned, or no, while I was tinning it for the first time, I was shaking solder off and I smacked the mat really hard and fractured the end of the tip. So the tip's actually damaged, but it's still working pretty good. So this soldering iron, this Schneider 50 watt from Harbor Freight, it came with decent tips. I've got no complaints thus far. It is a 24 volt iron, so it's not going to kill you taking it apart, you know, whatever, you know what I mean. All right. There. Okay, now this, I'm not going to worry about the middle pin right now because like I said, I'm going to use the actual body of the chip. Okay, alright. Okay is what I'm trying to get into. So I'm just going to worry about the 2 ends, the in and the ground, and then the output will just be the body of the chip. Try and get that situated there. And put that sucker in. Goes. We'll pop one more time just to make sure the solder flows to the other side. There we go. Now we got our chip in our prototyping board. First step down. Tin iron. I try and take care of this tip because I hate soldering with bad tips. So, okay. Now let's see here. This is the input. Let's see. The number 1 is the ground. That's the output and the input. So actually, I think I am going to try and get that center pin soldered because I want to put that capacitor on it. So let's do that. It's very short. It actually has a gap on the other side of the board, so I'm going to need to put quite a bit of solder in it and just let it flow to that pin as best as I can. take my meter, put her on continuity, and I can check that by taking the middle pin, the body, doesn't look like I have enough solder there yet, so let's try that again. Unless I blew the chip up, which is entirely possible. Now it looks like it's soldered there. Let's try it. Yep, okay. Good there. So I do got the middle pin soldered now. That was a little easier than I thought it was going to be. Just kept feeding it solder. Okay, now we need the input to have a 10 microfarad. So the ground is actually the first side. So I'm going to take this capacitor, chuck it right across there for now, and I'm going to see where I want my other capacitor. It has to go input to ground. I think I'm going to throw it right there. Why not? I can always throw rails later. This is actually, I can use the leads of the actual capacitors to dumb down the amount of rails I need to bend out and use later on. So this will actually be helpful. Alright, let's try and get those soldered. I'll use my helping hand. One hand for that. One-handed in the dark, as his uncle says. Holding the soldering iron in my teeth. That's the first time I've ever done that. Okay, let me clean that tip again. Flux on it. There we go. Retin that. Nice and fresh all the way around. Okay, now let's see if we can get these in there. Two down, two to go. Three down, one to go. Let's switch hands for this. Need a little bit more flux. Okay. Got our capacitors in. They ended up relatively straight. First try, not bad. Let's see, what do I want to do now? I can take my grounds, use my grounds as my actual feet over. And let's see, I can actually bring that up, bend that right. That way, when I come down, I can have a little rail that I can actually take some alligator clippage off of. Take that back down. There we go. I'll use 1/10 for that. I think that got it. Yeah, I got it. Simple enough. I'm going to take my other ground and see if I can do the same thing. Bring that 90 up, cut the excess off, bend it down, bring that rail to the other one. And when you bend these leads around, you can heat up the backside with some more solder just to reinforce it. After bending it around a lot, it makes it pretty weak, so you can kind of re-solder the rail in there. Okay. Okay, and I'll put some more solder in the back of that. There we go. Okay. Now that my grounds are together, take my other leads, do the same thing with them. I'm going to mark where they come down on the solder point, bring them back up, and bend my mark at a 90. Cut the excess off of my 90. Cut the excess off there, bring it back down to the point. Now you got a nice little rail there when you go to solder it. It'll be easy to bring alligator clips and stuff like that off of it. That's the whole idea. This is just simple, brain dead, simple stuff. There we go. Get that rail soldered in. Notice once you start doing this, it's not so easy. Once you start getting one solder point between, like this thing was a nightmare and took me days, but it was really rewarding once I got it done. I designed this completely, by the way, a full-blown manual EEPROM programmer. Okay, take our last lead here, do the same thing, take it down to the solder point, mark it with your nail, bend it over your nail, cut your excess off your 90, bring it back down to the solder point, and give her what for. little more off that. There we go. Okay, nice rail here. Okay, there we go. Now I have my output rail right here off of the actual chip. I can come down like that and pull 3.3 volts off of the actual chip, just like that. And now we're going to make a couple rails to go along the sides here, and those are going to give us more points to bring alligator clips onto. I'm going to go ahead and turn the soldering iron off for now, clean my tip, put a bunch of flux on it, find a clean spot on the sponge, and just really give it something. There you go. That's coming along pretty good. Actually check my solders with the multimeter. Just go from one point to the other. Good. And you want to go from solder to solder, not rail to rail, because if you miss the rail with the solder, this will tell you. Go. Everything looks good. Now I'll cover the flux up for right now. We're going to take a second. We're going to take a second and actually get these rails bent out. So kind of figure out however high you want them. I think I'm going to go, actually I'll use the needle nose here. I think I'll go about, let's see, about there. I want them pretty high. I want to be able to really grab onto them and not worry about the capacitors next to them. So there we go. Now I'm going to try and go from the hole it starts at. I want to go 1, 2, 3, 4, 5 holes over. So we'll just pick a space off of our project just to get these holes lined up. Give it a little bend backwards where I want it. That way I can come in here and it'll be close. It'll be close, and then I can fine tune it from there. Drop it in the hole. See how it fits. A little too wide. So I'll bring it back. That much. Perfect. I'm going to go ahead and duplicate that. Cut the excess off of this first. And do I have enough room to... Yeah, I've got enough room to duplicate that, just barely. Okay. Try and get a mark for it. There we go. And do the same thing. We're going to drop it in here. Line up our hole. Give it a small kick right over our nail. That way we can see where we need to start. On those. try that. And first time. Great. I'm gonna go ahead and take that one, cut the excess off of it. There we go. So I've got our two rails for the ground and the input. And then, like I said, my output will be the chip itself. Alright. Let's see if I actually have enough room on the side of those capacitors. Grab onto it. Yeah, I've got enough room. It'll be alright. Okay, now usually I want to try and bend these just enough to try and get them to stay in the hole at the elevation I want. Otherwise I have to try and wedge something underneath it. That starts to get messy. Okay, now I bend the top sides so I have just enough elevation, about as much as I want. I'll grab my helping hands. Actually, I'll go ahead and get the other side in there too, how I want it. That way I can turn on the soldering iron, get it all done at once. There we go. Try and make them have a somewhat equal altitude here. That's good if I can keep from knocking them around too much. Kick on the iron. Make sure to clean it before I re-tin it. This thing gets hot too. It's hot quick. I like this iron. Can't say that enough. Actually, need to roll this. I've never been used before. Go and knock these rails out. Now all I pretty much have to do is jump her over to the chip. So what I'm going to do for that is I'm going to take my lead, kick them over, cut whatever excess I don't need. I only need a tiny bit of this lead just to help the solder bridge so that when I start heating up the solder mask, the solder doesn't try and jump away from itself. There we go. One more side. Actually, I'll start it bending first. That way I know how high the solder goes. And like I said, the solder mask gets hot, solder is going to jump away from it, so we want to use that, however much of that leads left, just to bridge it. Go. Looking good. I need to get a freaking fume extractor for this thing. I think that little Heiko box is, I mean, that's good, but you could do the same thing with a fart fan and some charcoal. So I just want it that way. Okay, so this side of the rails aren't doing anything, so I'll just go ahead and cut the excess off of those, make it look pretty. Okay, absolutely simple, ridiculously simple build out of parts I had laying around. These capacitors are probably in here of different sizes, so I probably could have gotten away with trash capacitors. I just happen to have a couple brand new caps, electrolytic caps, so I went ahead and used that because I had it. But you can build this 5 to 3.3 volts out of garbage. Everything you pull out of the garbage that has electronics in it has a part you can use, all of it. So every time you go to throw something away that's electronic, you realize there's transformers, there's capacitors, there's inductors, there's big resistors, backfeed resistors, special Zener diodes and stuff like that. You end up finding a lot of really good stuff. Cans, oscillator cans, stuff like that. So try and get these rails straight just to satisfy me. Okay, let's test this thing out. Okay. Negative. I got a USB cable with the end cut off and the positive and negative stripped back a little bit. And my outputs, or actually I don't need that for outputs, I can just check it with the meter. I'll have one, that way I can clip it off of the, just so you can see where I'm pulling it from. Okay, so from the board we have pin 1 looking at the front side of the chip. This is the back side where it's facing down in SMD configuration. So on the left side is going to be our ground. Clip to that rail. The other side is going to be the hot. That's pin 3 over here because the middle pin's short, and that's also the back plane of the chip itself. So this is actually pin 3. Pin 1's ground, pin 2 is output, pin 3 is input, and the body is also pin 2. So okay, and there, and then where we're going to be pulling the 3 volts off, right from the back body of the chip, right on where the SMD would normally solder. Solder's still on the chip. This is trash parts here, so this costs nothing. This would cost anybody nothing. The parts are there. Okay, I got my positive and negative here stripped back a ways from USB. I'm going to go ahead and plug that in my computer. No, I'm not worried about it. Okay, I'm going to fold the negative down and clip it to itself. That way I can make sure they don't short out. And take the input, that up to hot, set that over there. Now I want to kind of feel around, make sure nothing's on fire, make sure nothing's hot. Everything feels nice and cool, no problems. So this should be our output. And I'll pull one more off of our ground. We'll use a common ground for the 5 and the 3 volts. This should be putting out 3 volts from my computer's 5 volt USB port. Let's take our multimeter here put it to a 20 volt rating on the DC side. Make sure it's all shorted out. Hook up my negative. Hook up my positive. And there we are. 3.3 volts. Thank you for watching. This was the simplest thing you could possibly build. I just needed this to see if it would charge an 18650 cell, which we'll see if it does. Actually, I'll do that right now. I'll see how hot this thing gets. So this 2 bank of cells right here that I pulled out of an old laptop battery, I know draws quite a bit. It should still have some voltage in it. I was trying to charge it yesterday. This was the one that made the Arduino actually get hot, even though it was absorbing voltage. So let's see here. See if it has anything left in it. Yeah, almost 3 volts. Okay. So we'll go ahead and throw this on here and we'll just kind of feel around, make sure nothing's on fire. I'm not sure if this is going to get hot. We'll figure it out. Like I said, trash components. I'm not worried about it. Actually, I want to hook our meter in here. Just get a reading for that. Okay, we know the battery's 2.6. Now when I put the ground side on from our 3.3 volt, it should go to about 3.2. And charging quickly. Now we want to feel our board. Oh yeah, she's getting warm. She's getting warm quick, fast, in a hurry. Yeah, she's getting warm. So we'll just go till she blows. More fun than it's worth. See if I can stick that in there. There we go. Battery's already up to 3.3. So now that the battery is actually up to 3.3 volts, it should not get super hot. Yeah, it's warm, but I can touch it. That's great. So as long as I know that the 3.3 volt cells are at 3 volts at least, I know this thing is not going to catch on fire. Up to 3.31 now. So that can just sit and charge pretty much all night long. Yeah, that's a lot cooler now. Now that it's 3.3 volts, it's getting cooler. I've got an official 18650 charger for $0. A piece of prototyping board, not necessary. A few alligator clips, not necessary. Solder, wire. The caps, capacitors, obviously were not necessary. I tried it before. Obviously, if you put it on there without a capacitor, it might draw a lot more voltage through it, which makes it a lot hotter, and you may burn it out quicker without the cap. So the caps probably help alleviate the ramp up on the chip. So yeah, that's great. Now I got some 3.3 volt cells laying around and a way to charge them. Thanks for watching. Take care.